And then let me share my screen. Can you all see my screen?
Yeah, it's visible.
Okay, cool. So hello everybody. And Swati, thank you for the introduction. As Swati said, my name is Anudeep. I work in the space of AI. I did my undergrad in India, worked in India for 4 years, then went to the US, did my MBA there, worked in early stage tech companies as a product manager in San Francisco, and spent 5 years there. And then, right in the middle of the pandemic, or the second half of the pandemic, I decided to drop everything, move back to India, and teach myself artificial intelligence from ground up because there was something about it that was really interesting. So that kind of brings me to today. I exited a company in the past, and now I am building another company. And over the next few months, I will be talking a little bit more about it. So if you're interested, please follow me on LinkedIn or Twitter or wherever you all get your news. With that, let's get started. So the thing that interested me most about generative AI is the fact that this was a new form of neural network that was able to pay attention. And what I'm going to try to do today is going to be a fairly starter level, but the aim is to help you build an intuitive understanding for this concept called attention, which is very important for most of the generative AI that is happening today, most if not all. So essentially attention is the focus of this talk. So to get started, let's take a very simple sentence. Let's say I am a human and my name is Dash. Now, as a human, if I ask you to fill this blank, there are many ways that you can fill this, right? Um, there are many ways that you can fill this. So, what are the options? So, okay, you can say Jyoti, Ram, like any of the number of names that exist in the world, you can like probably fill it in here because it's a human and a human can have any name. So this is how we're using our super advanced human brain are filling in this blank. But a machine is not as intricately talented as a human is. So with a machine, you need to tell it very exactly what to do, and then it'll do it. So with most artificial intelligence, you know that there is a training phase involved. So in the training phase, you give it a large amount of data, data in the form of sentences, and then it uses these sentences as a lookup table to figure out, okay, what should come here. Okay. So let's go step by step. And in these steps, we will be going through essentially the last 20 years of artificial intelligence. Okay. So the first thing that we'll be looking at is a window-based model. So in a window-based model, what you can do is, okay, artificial intelligence, this is what the task I'm going to give you is. Focus on the word right before the blank, and then use that to fill in this blank. So that is something that a machine can understand. So what it is going to do is it is going to look at the entire database, that all of the data that it has, look at all of the sentences where the word is shows up, and then it creates a frequency table of what is the word that comes after it. So there's multiple options here, right? So it's so for example, one sentence could be he is happy. Another could be his name is Sam. A third could be Martha is alive. She loves a girl and her name is Beatrice. that food is spoiled. You could also have like just a full stop after this. He is, full stop. Another could be like in between a sentence. A Zoom call is not fun. So what the machine is going to do is it is going to look at all of the sentences and create a frequency table of how many times does happy come after is, how many times does Sam come after is, how many times does alive come after is, and do this for every occurrence of every word after the word is. And then it will choose the word that comes most frequently and then say, okay, this is probably likely the word. Okay, but you as a human know that that's not the right approach, right? I am a human and my name is spoiled, for example. That does not make sense. I am a human and my name is not, unless like some super futuristic Elon Musk child whose name is not, like unless that's the case, like not is generally not what comes after is. So this is a problem. How can we solve it? Okay, but we could increase the size of the window. So here the window size was 1. Here, let's make the window size 2. Okay, now this is helpful. So now the machine is going to look at the entire data that it has, look at all occurrences of the sentences that have the word name is followed by a word. Now, because name is, now the machine has effectively reduced the amount of options that it has to the ones where name is like both of those words occur together. So here, your output is a little better. So like, for example, her name is Jyoti. He was born in the US and his name is Sam. Joe's band's name is Jonas. She loves a girl and her name is Beatrice. The cook in the ship's name is Guillermo. The founder of Rxol's name is Adebayo. So, okay, this is better. Like we as a human know that this is better because clearly all of these are names. Okay, so again, here we are going to create a frequency table and then it's going to give us the word that is the most common. Now there's a problem with this. There's a few problems. One of them is that every time the word combination name is comes, then the word after that is going to be the same every single time. This is the technique that is used inside your keyboard. So when you type a word, the iPhone or the Android suggests the next word, right? So it is doing this. That's why if you just keep choosing the next word, it'll kind of go about into roundabout sentences. The sentences don't really make sense, but it's the most frequent word that comes after. So this is better, but with this, you are creating very deterministic sequences. So every time name is, it will come with the same word. So this is not how we do it, right? So that's one problem. Another problem is, let me change the word human and say, I am an Indian and my name is. So this is the thing that I was telling you before. I changed one word, but it has no effect on the later things that are happening. It's still going to be the same predictions. It's still going to be the same words. And the system really hasn't learned like a whole lot, right? So how can we make this slightly better? Okay, we have a few options. One, we can increase the window size. So initially we were looking at only 2 words. Name is followed by this. Now let's increase it a little bit more. So now it's 3 words. My name is dash. It's still not going to be much better. But if you go all the way down here, that means the window size is 1, 2, 3, 4, 5. So if the window size is 5, then the word Indian gets selected. So if the word Indian is selected, then likely we will come up with an Indian name, because that's what you would expect, right? If I am an Indian and my name is Jonas, that doesn't make a lot of sense. It's not that it can never happen, but probabilistically pretty low. Rather, if it came up with something like Shiv or Raj or Jyoti or Sita or something like that, that's much more like within our probability with the way that we think. So all the way down, when you increase the window size to 5 words, is when you can come to getting better predictions. Okay, so is this better? Yes, it's better, but there are some major disadvantages with it. And I'll go through one of the biggest disadvantage with this, which is that the amount of data that you need exponentially increases. So what the machine is doing, as we talked about, is it is looking at every time. So when the window size was 1, that means only is was included. Then it is looking at all the sentences that have the word is, and then looks at all of the words that come after it and creates a frequency table. If the window size is 2, then it is looking for every sentence that has these two words in the exact order, which is name, is, and then it is going to look at all of the words that come after it and it's going to create a frequency table. When the window size is 3, it is going to look for exactly these 3 words occurring in this exact sequence and then look for what is the word that is going to come after this. So at this size, it may never see a sentence that has this, or it may see one sentence and that's it. Because this sequence of words coming again and again and again is pretty, like, it's not very high. And even if it does come, it's not going to be a huge number. So this is a major disadvantage because then it overfits to the data. What you want is a model with general capabilities. If at a window size of 5, you need like that many sentences to get these words in order, that's not really a good design, right? The second problem also is that we kind of saw that when we extended the window size to 5, then we included the word Indian, which would then help in making the prediction. But we have to fix a window size. How do we know what window size to fix on? Because this could be a longer sentence and the word Indian could have come much earlier. So you would have to increase the window size to 10 before really including that part into the prediction. So all of these are major problems. And that's why, like, the models that came out at the start, they were not very good. Like, a human could easily tell that this is a machine talking to me and not another human. Okay. Let's try one more thing. Instead of paying attention to all the words, let us be selective in our attention. So what we do is, let's just pay attention to the word Indian and these two words name is. Because we know intuitively that the word and, my, I, am, and an, they're less important in making this prediction. So that helps a lot, right? Now you are seeing, by knowing what to pay attention to, we are not then able to reduce the space to words that are Indian name sounding. So this is a big step forward. And we accomplish this by paying attention to the relevant words. This concept of attention has another advantage. We need much lesser data. So we don't need a sentence to always have I am in Indian and my name is before you're able to use that in your prediction. Any sentence that has the word Indian and name and is sufficient, because it knows that that combination of words is important. So you are able to accomplish a lot more with a lot lesser data. This is a big design update. So that's a big step up. Now, this concept of knowing what to pay attention to in predicting the next token or the next word is at the heart of all of the advances that are happening in generative AI. So this is specifically this thing here, this specific architecture is called a transformer. In the transformer, this part of the block is concerned with exactly the thing that we were talking about right now, which is the neural net is by itself able to understand what parts of the sequence to pay more attention to and what parts to pay less attention to. Before the transformer came in, you were following more like this type, where like every word was almost equally important. Once the neural network architecture understood what portions or what things to pay attention to, the quality of its outputs like became surprisingly better. And all of these things that you see above, they were all being done in the previous neural networks. This part is nothing new. All of the new advances come from just this block, which is called multi-head attention and masked multi-head attention. If this is something that interests you, just search for this term. Attention is all you need, and you will get a lot of articles talking about this. And that's in fact the name of the report as well. So it came out in 2017. It came out of the Google, the Google AI lab. And so ironically, Google was not able to take as much advantage of it, even though it came out of its own lab. OpenAI realized the importance of this architecture and started investing everything they had into building this up. And that is why we have GPT as like the foremost model now, and Google's Bard and everything, and Palm and everything is still like a few generations behind OpenAI stuff. So it's very interesting where the innovation came from and who made the best use of that innovation. But this this part is the innovation. What part of a sequence to pay attention to. And this is ultimately at the center of like all modern generative AI. So attention. So here, for example, if you say, how much does a pool add to home insurance? You see the color, the depth, how red it is how important it is in the overall prediction. So the word pool is very important, much is lower importance, insurance is fairly important. And then this importance sequence, this attention sequence is used to predict the next word, then the next word, then the next word. And essentially it just keeps doing this again and again. So a transformer like GPT or anything like that, Chat GPT, it is basically outputting one word after this. So this you give as the question, it outputs the first word, then it takes the whole this part plus the generated token and then runs it again. So it generates one token at a time. That's it. And you see in the tokens that it generates also, it is figuring out which parts are more important in writing the next piece. This can even be translated to image. So in the image also, a fairly similar architecture is happening, where because of attention, the neural network is automatically able to figure out which parts of the image are more important than the others. So here, if you see the bulbul, it automatically knows that the outline of the section is more important than the surrounding area. Same with the dog, same with this pen. And ultimately, this is what is happening with all of modern AI. So the current paradigm of generative AI is pay attention to the right fragments and use that to predict the next word or the next fragment, and then repeat. Generate once, add it to the overall thing, push it through the transformer again, generate the next word, repeat, repeat, repeat until the end. This is all that is happening in generative AI. So that kind of brings me to the end. I hope this has helped you understand a little bit more about what is happening intuitively in the heart of most generative AI models. And the really interesting thing that this shows up is, and this like should like cause you to ponder, which is this all that we humans do? Like when I'm speaking, am I intuitively doing the same thing? I'm generating word by word. And when I'm generating it, I know which portions of what I've said is more important versus less important. And I'm using that to generate the next word again and again and again and again. Is this all that we humans do? Or do we do something more? Or do we do something completely different? This is what the question, this is the question that generative AI has unlocked for all of us. So yeah, so that's it. I hope this was useful. And thank you. I'm going to transfer control back to you, Swati. Thank you all. If you have any questions, you can just drop it into the chat window. I have like 5 minutes. If I can answer anything, I'm happy to answer.
Is Satyam there in the meet?
Yes.
Yeah, sure.
Okay, Harsh asked a question. Can GPTs really think innovatively and not just mix and match the answer from its training data? Mm, Innovatively is like a very loaded word. I don't know what the word innovatively means. You, I can make the case that you are a collection of all of the language that you have been trained on from when you were born. All of the things that you heard on the TV from your parents, from your friends, all the books that you read. Um, I can make the case that that's the training data, and everything that you are generating out of that is essentially mixing and matching the things that you have. So innovatively is, I mean, I am, I would say that humans are able to um, think innovatively. A GPT is able to very elegantly mix and match and output things. But that question, innovative, is a very loaded word. So I don't know whether it is innovative or not. But if you ask me the question creative, then yes, I would say that human beings are creative. And the chat GPT is not. For example, can chat GPT make novel moves like Alpha Zero in chess? No, because what an Alpha Zero is going, or what like a GPT is going to be doing, is it is going to have consumed a lot of text on chess games. So it is going to know what are the best opening moves. It will have seen many games, many games in its training data. So if it sees a game similar to what it has seen in its training data, then it will be able to predict like what is a good move after that. But if it experiences anything that is out of distribution, this is a technical term, OOD, out of distribution, then it doesn't know what to do and it'll just like randomly choose something. So what human beings are much better than an AI at is with out of distribution data. So stuff that we have not seen, we're able to generalize much faster. But AI is better than a human when it comes to in distribution. So if it is something that like an AI has seen in its training data, it is going to be able to recall that faster, quicker, and more accurately than a human being. So if you're in the job of just doing that, which is recall and regurgitate, then like an AI is going to come for your job. But if you're doing creative stuff, that means you're doing things that has not been done before, then you're going to fare a lot better. So yeah, hope that answers the question. Maybe. Innovation is a very loaded word. Creative is an easier word to like work with. But AGI, the way that they define it is you should be able to do things that you were not trained to do. And people say that it can happen in the next 5-10 years. I would be surprised. I think we understand so little about the human brain in terms of analogously where we are with our understanding of the human brain is, if you compare it to physics, it's the equivalent of Galileo dropping a ball from the Leaning Tower of Pisa and realizing, oh, gravity acts on everything the same. That's literally where we are with our understanding of the human brain. So we need like a Newton, an Einstein, a Maxwell, and so many other people before our understanding comes to like the current level of physics understanding. So without knowing anything much about the brain, people saying like, oh, we're going to have like AGI in 5-10 years, it sounds very far-fetched, so to say. Cool. Thank you all.